To handle the examples here, I'm going to go ahead and put them together in a separate file from where they had originally appeared in the summary information for the introduction and measures topics. So we're going to go ahead and work our way through these examples here one at a time. The first example refers to using inductive reasoning. So we want to come up with some sort of general conclusion that would be based on observations about the numbers that appear in this list. We would like for things to be as basic as possible, so we would want to consider at first, basic ways that we can move from one number to the next, So we could consider things like adding, subtracting, multiplying, and dividing. Well, adding and subtracting are far nicer for us to try to come up with than the multiplying and dividing, so let's start there. In order to move from 1 to 6, well, one way of doing that would be to take 1 and add 5. So we could start with that observation and say that for between these two numbers, we would be looking at add 5. Well, let's see what would go on if we work from the second number to the third. Well, to start at 6 and move to a 16, we would be looking at adding 10. Still not able to pick up some sort of observable pattern here yet. So let's keep going and say if we're going to move from 16 to 31, then turns out that that would be adding 15. Oh, now we've got a pattern that seems to be going on. Let's see if it holds up as we move through the other numbers in our list. It seems like we're going to be adding a different number each time, but the numbers we're adding are these nice multiples of 5. 5, 10, 15. The next one would be 20. If I go from 31 and add 20, I do hit 51. Let's see if we can take the 51 and add 25 and get, and we do, 76. And if we take the 76 and we add 30, we get the 106. So it looks like what we would need to do for the first blank to fill in is start with the 106 and add 35. So that would give us 141. And then back to the pattern that we've got going on. To move from there, we would want to add 40. 141 plus 40 would give us 181. And to get the last number that we need, it seems that we would start with the 181 and add 45 so that we would have 226. In the next example, we need to round 23,487 to the nearest thousand. So, according to our directions for rounding, we first need to identify the place that's mentioned. The end of our number is the ones place, then the tens place, then the hundreds place. So the 3 is in the thousands place, and we will want to have an answer that would end with that place. So we need to know what do we do with the 3 that is currently there. Our directions tell us we need to look at the number to the right. The number to the right is a 4, and this would mean that we are going to keep that 3 the same. Therefore, the answer that we need is going to begin with the 2 that we originally have at the front. Then we're going to have the 3 that is staying the same. After the place that we have in our directions, all of the other places will be filled in with zeros. So we have 3 more places after the number 3 that need to be filled in with zeros. And that would give us a final answer of 23,000. Next, estimate the cost of filling your gas tank with 7.614 gallons of gas at $2.05 per gallon. For estimating, what we're looking at basically is rounding our numbers to a convenient form. So our gallons, having 3 decimal places, well, that's a bit overkill if we just want a ballpark idea. But maybe if we just go ahead and round it to the nearest whole number, we can get a decent idea of how things would play out. The same comment for the price of gasoline. Since this is really close to $2, why not just call it $2 and get ourselves in the right ballpark? So for our gallons, we're starting with 7.614. We're going to go ahead and estimate that as 8 gallons, because we would be looking at the 6 and saying that'll bump up the 7 to a full 8 gallons, just to give us something nice and convenient that we can do quickly, and that the $2.05 would be bumped down instead to $2 per gallon. So our estimate for the cost uses these values. We're going to need to, in this case, multiply 8 times the 2 to get 16, and that would be $16 for filling up thereabouts, approximately. The next example moves on to the topic of ratios, where we're being asked to find the fuel efficiency of a car that drove 429 miles on 12 gallons of gas. The reason why that is tying in with ratios is because when they ask us for fuel efficiency, they're referring to the miles per gallon. And that's the word version of the ratio. The math version in symbols would be number of miles divided by, or over top of, the number of gallons. So what we would want to work out in this particular problem is specifically 429 miles divided by 12 gallons. So, working this out, we've got our division. The 12 is going to go in front of our long division symbol. The 429 is going to go underneath. And then we start working our way through, or if you would like, you can also use a calculator and see if you come up with a nice answer here. Anyways, working it out by hand though, 12 goes into 42 3 times, and that would give us 3 times 12 is 36. Do a little subtracting here. 42 minus 36 is 6. So 12 goes into 69 5 times. That gives us 60. We get a remainder of 9 going on. So if we continue going with our division, we would need a decimal point that we would bump up behind the 35. We would need to throw in an extra 0, and we would carry that extra 0 down after the 9. So that 12 goes into 90. 7 times. Put in one more extra 0, and that should be enough for us. 12 goes into 60 5 times. So we get our remainder of 0, and we would have our answer that the fuel efficiency is 35.75 miles per gallon is the usual abbreviation for that. Let's give ourselves a little bit more room. To work out the next problem, we are looking at now finding the value of an antique car that was worth $12,000 but has appreciated 35%. This is referring to a percent, so we would have to use our understanding of percent to work through things. Because it mentions appreciated, we would have a percent increase specifically. They give us 35% as the percent increase. So, the new value is going to come from the original value. Increase means we're going to add. So, plus, keep it in the blue, plus 35% of the original value. So, the original value that we have mentioned in the problem is $12,000. The decimal version of the 35% is going to be 0.35 or 0.35. And we're going to need to multiply that by the original value, that 12,000, so that we can come up with our final answer here. So the $12,000 plus, to do that multiplication, again, you're welcome to do it by hand. You're welcome to use the calculator. to come up with that. That we would have $4,200. So adding those together, 16,200 officially. So to make it fully official, we are referring to a dollar amount. So $16,200 is the new value. The final examples that we have deal with measurements and being able to convert from one type of measurement to another. So first we have the example where we would like to convert 4.75 kilograms into grams. So we would need to know how to change between kilograms and grams. We need a conversion factor. And to set this up, what we would want to have is the kilograms being canceled by kilograms on the bottom. So we need some sort of conversion that goes between kilograms that we will put on the bottom and grams that we will put on the top. So the relationship between those is based on that prefix kilo. Kilo meaning 1,000. And what that specifically refers to in this case is that 1 kilogram is equal to 1,000 grams. So what we have is that the units of kilograms will go away. They will cancel each other out. And when we do our multiplying, 4.75 times 1,000 gives us 4,750. If we take that and divide by 1, we still get the 4,750. And the units that remain are the units that we desired, grams. Next, converting 78 degrees Fahrenheit into degrees Celsius, that we would want specifically the nearest tenth of a degree Celsius, means that we're going to have to use a formula that will transform us from from Fahrenheit into Celsius. So we would need a formula that gives Celsius equals, and that formula says 5/9, parentheses, Fahrenheit minus 32. We're going to put in the Fahrenheit temperature in our formula. So 5/9, and then in parentheses, 78 minus 32. 78 minus 32 gives us 46. So if we take that 5 times the 46, we'll get 230. And if we take the 230 and divide it by 9, we'll be ready to give our rounded answer. We want to round to the nearest tenth of a degree. So when we look at the calculator display, we've got 25.5. That's the tenths place, but remember we need to know what's beside that has control. So the very next number is another 5. So the 5 that's in the hundredths place means that I need to take the tenths place and round it up to a 6. So that my final answer based on the directions, 25.6 degrees Celsius. And finally, convert 1 mile to kilometers, given the conversion that 1 inch is equal to 2.54 centimeters. Okay, we don't have inches yet, so we're not ready to use that. What we have to start out with is miles. So 1 mile. We need something that will allow us to go back and forth between miles and eventually inches, but we can start out with the fact that 1 mile has 5,280 feet. So that gives us a way of being able to start getting close to inches, because then we can say we need to cancel out feet on the top with feet on the bottom. 1 foot is 12 inches. Now we have inches, and we can switch over 1 inch based on the conversion that we were given is 2.54 centimeters. But we also need to move from centimeters to the kilometers that are mentioned. So first of all, we can use our prefix information. 100 centimeters in 1 meter, and then 1,000 meters in 1 kilometer. So we need to multiply all of the numbers across the top and eventually then divide by what we get from multiplying all the numbers that are along the bottom, just to make sure that we've got everything working the way that we need. Remember that our units should eventually be transformed from miles to kilometers. So let's go through and make sure that that works properly. Miles slashed with miles gives us feet. Feet slashed with feet gives us inches. Inches slashed with inches gives us centimeters. Centimeters slashed with centimeters gives us meters. Meters slashed with meters gives us kilometers. So we do have our units working out properly. So to go through the multiplication, we've got 5,280 times 12 times 2.54 times 1 times 1. So to work that out, we get on top, so 160,934.4, and on the bottom, 1 times 1 times 1 times 100 times 1,000 gives us 100,000 on the bottom. This will be kilometers here in just a moment. We do the actual division there. So we would have 1.6 0.9344 kilometers.